All right then. Well, it says the next thing we're going to do is we're going to write a program. We're going to create the following program. The National Earthquake Information Center has asked you to write a program implementing the decision table below to characterize an earthquake based on Richter scale number. Your program should read the number from the keyboard and display an appropriate message. All right, so I'm all set up to go here. Tell me what to type. Documentation. This program will ... I'm going to be lazy. You can't be lazy when you type up your programs. I can be. That's the difference. Okay, what comes next? Include IO stream. So I need a pound. Include IO stream. Using namespace standard. Semicolon on the end of that one. Very good. Uh-oh. If you spell namespace wrong, it doesn't like it. There you go. All right, what's next? Void main. Void main. And feed myself some. All right. So there's the basics that every program will start with that you need to type up. That was our quiz last week. So if you don't know that by now, hopefully you'll learn it soon. All right. Now what do I need to do? Introduce variables. Okay, so what kind of variables am I going to need? It looks like I'm going to need one variable. I'm going to need a variable to be read in, which is the n number. Am I going to call my variable n? No, I'm not going to call it n. Why not? We do not write programs where our variables only have single letters. Although some of you did that for your program, and I had to tell you don't do that. You can't call your variables x1 and x2. That's no good. All right, so what do we want to call it? RicNum. Okay. Is RicNum an integer, a double, or a character?
I would say that it is a
Float or double, definitely, right? Because we're definitely using decimal points here. So it's definitely got to be a float or a double. All right, so float RicNum. Variable for Richter scale value. All right, good. What's next? I better give the person who's running the program some information. So how do I do that? See out. Lesson. Oh. You will enter a Richter scale number. The program will characterize the amount of data, damage. Amount of damage done by the earthquake. Semicolon? We're going to end line, okay. End line, semicolon. Now, we might want to consider breaking that because it's a long line. We'll see. When we run it, we'll see how it looks. Okay, now what? CN? CN what? I would probably put one more C out that just says, please enter the Richter number. But you're right, eventually we need to see in. So I would be very clear in my directions, and I would say C out, please enter the Richter scale number. And when I have these CNs like this, when the person's going to type a number in, I like to put like a colon here and a space, just because when it runs, then it puts the space, and the person types the number in, it puts a space there. Is it wrong to not have the space? Of course, it's not wrong, but I like to have one there. And then CN. And then you told me for CNs I use double greater than. Rick, no. Is that it? All right, so I should document this, right? So I would say directions to the user and get data. All right, so notice as I go here, I'm not documenting every single solitary line. Are you expected to document every single line? No. It should be done kind of in blocks like this. So you have a block where you define your variables. That's good. Then you have a block where you do instructions and get data. You can just document that whole block. And it does help if you put some spaces in between. Helps it to be easier to read that this is kind of where one block is ending, and now we're going to do something else. All right, so now basically we need to build this table. All right, so what do I do to build that table? Start with if. Rick num is less than 5. Oh, I need what? Yeah, whenever you write the word if, what comes next? Parentheses. Whatever you're testing has to be in parentheses. That's why it has the little red underline. It doesn't like that. All right, that's easy to forget, but that'll show up there. All right, if Rick num is less than 5. See out? You'll be fine. Oh, I'm going to put out little or no damage. Little or no damage. You'll be fine. There. And I think I'll put an end line on this. I need the double lesson signs. That's a common mistake I'm seeing people make. Anytime you switch blocks in your text, you got to separate it with the double lesson signs. And I need an L, don't I? And L. There we go. All right, now what? I would put an else here. Okay. Else. Now an F. Do I need a curly bracket for my else? Yes, because I'm going to have lots of stuff inside this else, aren't I? I'm going to have all these statements. So I need a curly bracket. If Rick num is less than 5.5. See out? What's that one? Moderate damage. We have another funny line to say to the people. Brush it off. Walk it off.
Hold on.
Rub some bacon on it.
Rub some bacon on it.
Hold on.
You'll probably need to buy new dishes.
Or take your coals off the coals line.
It says moderate damage.
Yeah, so moderate might be.
Like a tree on your car.
Well, it depends on how much you value your car. I wouldn't call a tree on my car moderate damage.
Take that severe with her.
I'm thinking moderate damage, maybe some of my glasses get broken, perhaps a window at the worst breaks. I would consider that moderate damage.
You misspelled wrong.
I misspelled moderate. Moderate.
Yeah.
What is the moderate?
An earthquake is raging.
The earthquake is raging. Correct. All right, what comes next? Another else. So we're being very clever here. We're doing the nested else statements. We are not doing curly brackets. Thank you. We are not doing parallel if statements. So the next one would be if Rick num is less than, the next one is 6.5. See out. Serious damage. Get the tree off your car. Nationwide is on your side. That's the next one.
What's the next one?
Nationwide is on your side. All right, what comes next? It keeps going, right? Same thing again, else. Curly bracket. If Rick num is less than 7.5, see out. Disaster. Nationwide is on your side. Unless, of course, you don't have nationwide insurance. And
Then you're done.
then you're done for. Then nationwide will definitely not be on your side. Else. I don't need an if this time, do I? How come I don't need an if this time?
Everything else.
Because I'm at the end, aren't I? We tested all the less thans. The only possibility left is that number is bigger than 7.5. So we just need to see out.
I believe
Catastrophic damage. Tattoo your social security number on your arm. That's what you do for hurricanes.
Why are you still?
That's what you get for living in California. Anything else I need?
Close all your brackets.
I think all my brackets are closed. If my brackets are not closed, then one of them will have a little red underline on it.
Maybe you can put something in case they put something that's not right.
Almost like an error message.
Well, if they put in a letter, the program's simply going to crash because it's trying to read a number. So if they put in a letter, it's just going to abort anyway. It won't do anything. Don't have to worry about that. I do think there's one thing missing. Documentation. So I would go at the end of this whole if block. This whole if block ends right here. So at the end of this whole if block, I'm going to put documentation. What am I going to write? Test value and output appropriate message. Looks good. All right, well, let's try it, see if it works. Debug. Start without debugging. Yes. You will enter a Richter scale number. The program will characterize the amount of damage done by the earthquake. So something a little weird is happening here. You notice it gets to the end of the line, and then it is putting that space in right there. So again, that first line is pretty long. We might have wanted to split it into two C outs. Too late now. I'm happy with it. Give me a Richter scale number.
12.
12. Catastrophic damage. That's what you get for living in California. Let's try it one more time. Try a different number just to make sure it's catching one of the ones in the middle. 5.2. This is one that's kind of not right on an end. Moderate damage, you'll probably need to buy new dishes. All right, so there's nested if loops. Now, some of you this morning already had your lab, and you saw that your lab that you're writing involves nested if loops. Some of you will have lab later today, and you will see that that lab involves nested if loops. So your program's going to look an awful lot like this program that we just wrote right here. Questions about that program?
Why wouldn't we use else if?
You could. What he's saying is, right here, I have else. I could put else, and right next to it, I could put an if, and then put a parenthesis like so, and do exactly the same. I like to put them on another line, just because then it indents everything for me.
I'm thinking like the grading program we made last time. It's the same idea.
Yep.
So you said
I would accept either. This is, again, some programming comes down to preferences. This is my preference. I like to put the if on another line so that it indents, and it, especially if I mess up my parentheses, it makes it easy for me to see that this parenthesis goes with that one. They're lined up with the indentations. And so if I click on this one and I see it's matching up with that one, then I know I've made a mistake somewhere in my brackets and I need to go back and fix that. So again, that's my personal preference. It makes it easier. I find it easier to read that way. If you like doing else if right in the same line, that's fine too. It'll work. Other questions? All right then, today we're going to move forward and we're going to talk about switch statements. So a switch statement is actually very, very similar to an if statement. Anytime you use a switch statement, you could also use if statements. Switch statements are very often used for running like a menu-based program. So you might run a program, and the program might say, press 1 to enter data, press 2 to print the data, press 3 to do something else, so on and so forth.
When you're writing a program that's seated at graphical interface, and there's like 3 buttons, for example, you click 1, 2, or 3, and you click one of those 3 buttons, it's the same deal. It's just going to assign that button to that line of code. So click that button to run case 2, and click this button to run case 3, right?
Correct. That's what we're going to do with these switch statements. All right. So the way a switch statement looks, up above, we would have a variable defined up above here. And then you're going to have the word switch with a parenthesis, and you'll have an expression in there. So this switch expression, this will usually be a variable name. Usually. And we'll look at some examples here in a minute. And then we have cases. So you'll have case 1. So this is like if the person presses 1 on the keyboard, it does the first case. And then case 2 would be if the person presses 2 on the keyboard, it does something else, so on and so forth. So instead of having a case, this could be if. It could say if the person pressed 1, do a bunch of stuff. And then you could have an else. If the person pressed 2, do a bunch of stuff. Else, if the person pressed 3, do a bunch of stuff. So in theory, you never have to use a case statement, a switch statement, but they're kind of cleaner and neater when you're doing menu-based programs. Now, there are some restrictions here. This variable that you use, this variable can only be an int or character. So you cannot tell the person, type in your name and have, say, a string variable here as your test thing. Or you cannot say enter a number and the person enters 12.5. 12.5 won't work. It's got to be an int or a single character are your only choices. Cannot be floats, cannot be strings. All right, so it makes more sense when we see an example here. Go ahead.
We put switch statements inside of if statements, so if people incorrectly, like they put in the wrong number, it'll complement us to the same we need to.
Yes, you can have if statements within switch statements.
And switch statements.
And switch statements within if statements. You can do it both ways. Absolutely. All right, so here's an example. So up above, this is a little block of programming here. Up above, we define a variable called letter grade, and letter grade is a character variable. So up above here we have char letter grade. And then up above there's a CN letter grade. Alright, so then it says switch, and we're going to test on letter grade. So if the person typed in A, and it has to be a capital A in this case, again, C is case sensitive, then the program will output excellent. And then it will output superior. And then it will output average. And then it will output poor. And then it will output try again. And I think it'll even output not a valid letter grade. Is that what you wanted? No, what did you want it to do? If the person said they had an A, what would you like it to say? Just excellent. So break, that's what these break statements are about. So this is the way we probably want this one. So what this one will do now is if the person types in a capital A, it'll say excellent. It'll break, which means it jumps from break all the way to the end of the switch statement. Or if the person typed in a B, it would say case A, skip that. Case B, yeah, hey, I got a B. If the person typed in B, it would then say superior. It would break, jump to the end of this case statement. Why might you want it to do this, where if somebody types in A, I mean, it doesn't make sense for a letter grade, of course. Can anybody think of an example where you might type in a letter and then you want it to say this and everything below it? Maybe. Here's what I was thinking of, because I know there's a whole bunch of Boy Scouts in this room. It used to be with Boy Scouts when you sold popcorn, if you made a certain level, you got that prize, and you got every prize below. It used to be that way. Now they've changed it, so if you reach this level, you only get this level. It was getting too expensive, I guess. I don't know. But for some of you who have been in Boy Scouts for a long time, you might remember that if you got to you sold the $600 level, if you sold the $600 level, you also got the $450 prize, you got the $200 prize, and you got the patch just for selling something. You never got all that. Well, you're in the wrong troop. I can't help you that. Should switch troops, been in my troop. You'd have gotten all your stuff. Yes, I am a troop leader. Still, yes. In fact, Troop 79 over in Painted Post. And there's one student in this room who is in my troop and is an Eagle Scout, but I will not tell you who it is. Most of you already know who are already Boy Scouts. Anyway, so sometimes you might actually want that, where you reach a certain level, you also get everything below. In most cases, you're not going to want that. Certainly with this letter grade, you would not want that. You would certainly want the break for each one. Now, what's this default thing do? Correct. So you don't. When you use switch statements, you asked, "Can I put an if statement there in case somebody types in a wrong thing?" Well, you don't really need one, because there's something called default, and you can always use that to say you did not type in a valid code. So if the person types anything other than the letters A, B, C, D, F, it will default to say not a valid letter grade. So typically you don't need an if statement to test for bad data input when you're using switch blocks, which is kind of nice. Now, something to consider. The person might type in a little letter A or a big letter A, depending on your directions. If you just said enter your letter grade, some people might type capitals, some people might type littles. And you can handle that too. So you can handle that with case little a colon, case big A colon, see out excellent. So now if the person types in a little letter A or a big letter A, it will still see out excellent. And then it will break, it won't test any of the other ones. And down the line, if the person types in a little d or a big D, it will type the word poor. Questions on that?
does just that, and then it ends. And for C, if you put in, C, we're seeing if you put in lowercase, C has stuff in case in the future, for example, both lowercase, either lowercase or uppercase.
Correct. So what she just said is A, block A, wherever you start, if I, for example, if the user typed in a C, it's going to print average, and it's going to print everything below. Where block B is really what we would want for this program segment. If I typed in C, it's going to output average, and it's going to break. It's going to come to whatever happens right after this switch statement ends. It's only going to print average. But that's only in the case where you use a capital C. Where here, a person could use capital letters or little letters. And again, it will only print the correct thing. It'll only print one. It won't print everything below because we have the break statements. Questions on that? Okay. So, consider the following nested switch statements. So we have switch X. And again, you're not allowed to use single letter variable names, but I am. Case 2, case 4, case 6, and then we have a nested switch because inside a switch we have another switch, switch for Y. Case 1, case -1, case -2, case -3. Not that I'm aware of. It's just a matter of can you chase it and keep track of where you are, because multiple switch statements gets multiple confusing pretty quickly. All right, and then we have a, where did we end here? So then we have a 1, 3, a 5, a different switch Y, a case 2, 4, 6, a case -1, -4, -6. Oh, see out this stuff. All right, so the question is, if X is the number 4, way down here, and Y is the number -2, what is this going to do? X equals X minus Y. Why do you pick X equals X minus Y? Because if X is a 4, 2, 4, or 6 all get you into here. So you're absolutely right. So since X is a 4, it gets us into here. And then we do switch Y. Y is the number -2. If Y is -1, -2, or -3, it does this. So X is now going to be X minus Y, which means X is going to be the number 4 minus -2. 6. Good. I heard somebody say 2. X is going to be the number 6. And what about Y? Does Y change? No. So right here, X will be made 6. And then I see the word break. So where does the computer go? To the end? It goes, it'll jump all the way down to here. So it's going to print X equals 10, Y equals -2. All right. What happens if X is 3 and Y is 6? Go ahead.
I have a question.
Go ahead.
Does the break out of both?
Does the break it out of both switches? That's a wonderful question. So what he's worried about is this break, is it only going to take me to the end of this switch? Or will this break the entire switch block and take me to the end of there? That's an excellent question. It's only going to break the switch you're in? That's what you think? Because it's indented?
I don't think they would have printed it correctly.
Well, I will warn you that I'm the one who wrote this sheet. So the fact that it's correct or not is not guaranteed.
But even if it doesn't, none of the other cases match it.
But if it's
not
break,
break.
then it would use everyone anyhow.
All right, so the concern is, if it only breaks this switch, then it seems as though it would run this part, wouldn't it? Because it's not breaking out of the X switch. And then we would come down here and maybe stuff would happen again. Now in this case, we don't have anything to worry about because never is Y the number -2 again. So nothing else is going to happen anyway.
Remember, for B, wouldn't X line up equal 18 and Y 1 equal 6?
I believe so. Because for B, when X is 3, it's going to skip this. So it's going to come down to here. And then Y is 6, so it's going to run into here. So X will be 3 times 6, which is 18.
Like how A is X equals 6 and Y equals 22.
Correct. But the question still exists. What does this break statement do right here? It seems like it would only be breaking out of the first switch statement.
It's already the end of that, so what's the point of breaking?
All right, so how can we find out for sure what that break statement's going to do?
Just try it and run it.
Type it in and try it and run it, right? So let's do that. Because right now, I'm going to be honest with you, I'm not sure. I have my idea of what it's going to do. And after I try it, I'll tell you if I was right or not. All right, let me copy this program first so we can save it. All right, go back to this. So, all right, so I'm just going to do, so what I need here to test this is I need a number where X would catch here and Y would catch in this second switch to see if it's actually breaking out. All right, so we'll figure that out here. So we need int X equals 4. We'll just initialize our variables here. Int Y equals -2. Switch X case 2, case 4, case 6, switch 5, case -1, case -2, case -3, X equals X minus Y, break. All right. And then we need case 1, case 3, and case 5. God's not happy with me. Yeah, but that's just documentation.
It looks like his -1 is
Those should be with this switch Y. Correct. All right, let's try it. Switch Y. No, it still doesn't like it. Well, it doesn't say anything, it's just got it underlined. See out.
Mouse over.
Just debug it and see what it says. A case label may only be used within a switch. 20 by 21. Oh, I know what I did wrong. I needed a curly bracket to begin my switch X and a curly bracket to end my switch X. There's my mistake. All right, easy to make. Now, what I want in here, though, is I want one of these same numbers to happen again, don't I? So I want case -2. See how didn't break. All right, so now what should happen if X is 4 and Y is -2? I think, my opinion is, when it gets to this break, it's going to break everything, and it's going to jump all the way to the end of the case X. That's my guess. That's what I intended when I wrote this. Let's see if I was right. If I'm wrong, then it's going to have X equals X minus Y, and then it will also print didn't break, if I'm wrong.
Isn't it not going to see out if you didn't declare the CO at the bottom of the next switch? Like you have the case -2.
All right, so now it'll at least tell me what X is when it gets all done. If it didn't print anything, then I would have known that it broke and it didn't run the other part of the switch block. All right, let's find out, and then we'll know. I told you what I think my answer is. I think the break's going to break out of everything, but we'll soon know. And guess what? You can't see it. Haha. I don't have to tell you if I'm right or wrong. It did not break it. So it broke only out of the Y block. It did not break out of the X block. Teacher was wrong. Rats. Don't like it when I'm wrong. All right, so now let me ask you a question. How do I fix it?
Break.
Add a second break. Add it where?
Right at, or at the end of
After this curly bracket? All right, I think you're right, because if it runs 2, 4, or 6, then it checks the Y value, and then I want it to be done. I don't want it to test 1, 3, and 5. So to fix it, I think we would need to put a break right here after that semicolon, after that curly bracket. Should we test that? So we want to have a break right after the switch Y stuff. Break. And that did fix it. Now it only prints X equals 6, which is what we want. All right, so there's a lesson learned. Make sure you get your breaks in the right spots. And this is a nice little trick too that I do sometimes if I want to see if something's running or not. I put a C out and I have it print a message to me so I can tell if it's getting to that point in the program or not. So that's a good little debugging trick if something isn't working right and you're wondering, does my program run that block? Is it getting into that if switch? Is it getting into that C out, into that switch block like it should? Put a little C out and put a little message to yourself. And then you'll know if it got there or not. If it prints the message, it got there. If it didn't print the message, it didn't. That's a handy little trick. All right, so back to this. Now that we corrected it. All right, well, let's jump down to the end. What's going to happen now if, say, x is 7 and y is negative 2? It doesn't do anything, does it? So it looks, it never finds x equals 7, so what's it do? It just jumps right down to the C out, and it'll say x is 7, y is negative 2. Won't do anything. It's like there's no if. The if doesn't exist there. All right, well, I think that's the end of the stuff for today.